All right. So, yeah, today we'll just be going over your practice midterm, going over all the questions. So, starting with, I don't know, do you want to just go over every single problem, or do you want to tell me the ones you want to go over? Because I don't know if we'll have time to do all of them.
Well, in my opinion, so the first half of it is the first test, correct? So
Pretty close to.
is it mixed in? Or is
Some of the questions may be the same, but in general they're not.
okay, well, I was just thinking that you already posted a video of this. The first half.
So you want to start with problem like 20 or whatever?
Yeah, just doing those ones. And get
Okay.
those out of the way. And then we could go back to.
Go back and watch that video.
Yeah.
Okay, so let's see. Is it 19 where we switch?
It's,
No, probably 20.
It's 20.
yeah, it's 20.
Alright, so we'll start with 20. So in 20 we have u over 3 is greater than, make sure I'm writing the right stuff,
-2.
u minus 3,
Is less
oh,
than.
right, epsilon, is less than 2? Okay, so here's our two inequalities. These are being anded together. I think so, right? And, yeah. So these should be giving us an upper and a lower bound on some interval. That's ultimately what this is giving. Did I push record? Yes, I did. Okay. All right, so messing with this inequality, multiply both sides by 3. And this inequality is telling us that u is greater than -6. This inequality, add 3 to both sides, and this is telling us that u is less than 5. So u is greater than -6 and u is less than 5. So our interval notation is this is all the terms from -6 to 5. The way we write that out on a number line, here's -6, 0 somewhere right there, here's 5. We don't include that point, we don't include that point, but we include everything in between when we graph it out. Good?
Yeah, okay.
Okay.
What if it was an or though?
So an or wouldn't make sense in this context because it's combining the two together.
Oh.
So if it were an or, that would only make sense if this was saying that is like that and this is like that. So then that would be saying u is less than -6 or u is greater than 5. And in that case, it would be everything over here, not the middle, and then everything over here.
Okay. Okay.
Okay. So moving on to 21, solve the inequality and give the interval notation for what this is. I think graph it. So let's see what our inequality is. M over 5 is less than,
Equal to -6 over 5.
thank you. All right, well, that's a real easy one. Multiply both sides by 5, we get M is less than or equal to -6. How do you graph that out? Here's 0, here's -6. We include -6, we're going this way. In interval notation, that's everything from -infinity to -6.
Okay.
All right. Problem 22. An executive drove from home at an average speed of 40 miles per hour. So his first rate, rate 1, is 40 miles per hour. To an airport where our helicopter was waiting. The executive boarded the helicopter and flew to the corporate office at an average speed of 60 miles per hour. So our second rate was 60 miles per hour. Okay? The entire distance was 150 miles. So our first distance plus our second distance was 150 miles. And the entire trip took 3 hours. So our first time, T1, plus our second time, T2, is equal to 3 hours. Find the distance from the airport to the corporate office. So, let's see, we go from home to the airport and then the airport to the corporate office. So our second distance is the distance that we're looking for. We're looking for D2. Drawing a picture of this, what does it look like? We start out here, we're going this way at 40 miles per hour till we get to here, and then we're going this way at 60 miles per hour. This whole distance right here is what we mean by D1. This whole distance right here is what we mean by D2. Everyone understand the problem? We got our two rates. We know that the sum of our distances is 150, and we know that the sum of our times is 3 hours. Now, always and forever in these problems, what's the equation that we're using? Rate times time equals distance. So always and forever, the general equation right out to the side over here is rate times time equals distance. What does that mean in our particular case? That means our first rate times our first time equals our first distance. And our second rate times our second time is equal to our second distance.
Oh,
Right?
okay.
Or, now plugging in the values that we know, our first rate is, what's our first rate? 40. And our second rate is 60. Now I don't know what D1 is, I don't know what D2 is, but I know what D1 plus D2 is. Right?
Yes.
Yes.
So D1 plus D2 is equal to 150, right? But D1 is also this, and D2 is also this.
Oh.
So D1 is 40 times T1, plus D2 is 60 times T2. So we're kind of ignore the second half of this, and here's what we got. Distance 1 plus distance 2 equals our total distance. Okay, last thing we need to use is this equation, so that we only have one variable. Notice that we have one equation with two variables right here. We got to substitute out one of those variables using this equation. So we can replace T1 with T2, or we can replace T2 with T1. Which one do we want to do? This is ultimately the variable I'm solving for, D2. So if I know T2, I can calculate D2. So I want to rewrite this with only T2's in it. I want to replace T1 with a T2. From this equation I can. This equation tells me that T1 is equal to 3 minus T2. These two equations say the same thing, right? Look, right here I have two equations, two unknowns. I solve for one variable in one equation, substitute that into the next. Same thing you always do. So I solve it for one of my variables, now I substitute it in here. So now I know 150 is equal to 40 times T1 plus 60 times T2. Now I have one equation with one variable. I just need to solve for T2. Okay, so from here on out, piece of cake. So 150 is equal to 40 times 3 is 120. 40 times negative T2 is minus 40 T2.
Right.
Plus 60 T2. Let's simplify. Minus 120 from both sides, and I'm left with 30 is equal to negative 40 T2 plus 60 T2 leaves me 20 T2. Divide both sides by 20, exactly. So divide that by 20, divide that by 20, and we're left with, notice that the 10s cancel out, and we're left with 3 halves is equal to T2. Or in other words, time 2 is an hour and a half. It's 3.5 hours. Or 3 halves of an hour. So there's T2. So we now have T2, we're trying to find D2. Remember, the big picture, that's what we're looking for. So now that I know how long this part of my drive took, an hour and a half, I can figure out the distance this was. I was going 60 miles per hour, and I was doing that for an hour and a half.
Hi, are you missing any students?
Just Lucy. And so, it's just 60 times 3 halves, which is equal to 90. 2 cancels out with 60, leaving 30. 30 times 3 is 90. So D2 is 90. So it was 90 miles from here to here, and it was 60 miles from here to here, because my total distance was 150 miles. Good?
Yes.
Okay. That was 22, moving on to 23. Solve the inequality, graph the solution, and give interval notation. So let's see, we have 3 minus 2 absolute value x minus 5 less than or equal to minus 15. Is that right?
Yes.
Okay. So I need to isolate the absolute value piece by itself. That's step 1. So first thing I want to do is get the 3 over there. So I'm going to subtract 3 from both sides really quick. And so I'm going to be left with negative 2 times the absolute value of x minus 5 is less than or equal to, subtracting 3 from both sides is negative 18. Right? Trying to isolate the absolute value. So now what am I going to do? I'm going to divide both sides by negative 2. Because I want the absolute value by itself. I need to get rid of that negative 2. So if I divide this side by negative 2, and divide this side by negative 2. Negative 2 and negative 2 cancel out. So I'm left with the absolute value of x minus 5 is less than or equal to negative 9? Positive 9. If you ever get absolute value is less than or equal to a negative number, either there's no solution or you messed up. Okay, so now I know absolute value of x minus 5 is less than or equal to 9. Now we can break that up into 2 inequalities, right? If I know that absolute value of x is less than or equal to 9, then that gives me the absolute value, x minus 5 is less than or equal to 9, and what's the second one?
It's gonna be x.
Remember, you just substitute out both the positive and the negative have to satisfy this.
So it's less.
Huh? So we also have and negative x plus 5 is less than or equal to 9. Right? And these are our 2 inequalities. So from this inequality, working with this one, add 5 to both sides and we just get x is less than or equal to 14. Working with this one, what do we get? We get negative x is less than or equal to 4, right? And then divide both sides by negative 1 and we get x is less. When we multiply both sides by negative, we flip our inequality. So that's the same thing as x is greater than or equal to negative 4. So we have x is less than or equal to 14 and x is greater than or equal to negative 4. Drawing that on the number line, here's 14, here's negative 4, 0 somewhere right here, and that's all these points. Since we include them, we include these points. That's here to here, and we're good. You can always do a quick sanity check. Check your endpoints, plug it back into your equation, and make sure they work. So let's check it. Plug in negative 4. Negative 4 minus 5 is negative 9. Negative 4 minus 5 is negative 9. Take its absolute value, that's a 9. Is 9 less than or equal to 9?
Yes.
Yeah, so that one works. Now try your other point, 14. 14 minus 5 is 9. Take its absolute value, 9. Is that less than or equal to 9?
Yes.
Yes. So your endpoints here better give you exactly when it's equal. So that's a quick check. Okay, yay, we didn't mess anything up. And the interval notation is going to be, this time it's square brackets since we included negative 14, or negative 4 to 14, like that. Okay, gotta be tough. All right. Okay. Next one, problem 24, solving a system of inequality, or a system of equations. So, system of equations, we have negative 3x plus 3y minus 3x plus, someone want to read to me?
Equals negative 12.
Minus 12?
Negative 3x plus 9y equals 24.
Equals 24. Okay. We could solve one of these for x, substitute it into the other, solve for y. That's one way to do this. This one's screaming for us to add the two together. So first I'm going to multiply this by negative 1 across, and then I'm going to add it to this. So taking this equation, multiplying both sides by negative 1, I can rewrite this as 3x minus 3y is equal to 12. And now I'm going to add these two together. So when I add those two together, my x's go out, negative 3y and 9y leaves me 6y is equal to 12 and 24 is
12.
We're adding. I'm adding this to this, this to this, this to this. 36. Or in other words, y is equal to 6. If 6y is equal to 36, divide both sides by 6, y is equal to 6. Now pick any equation here that you want to figure out your x. Doesn't matter which one we use. Now we know y, pick one, we can solve for x. I'm going to randomly pick this one. No special reason why. So I know negative 3x plus 3y, I now know y 6, so plus 3y is equal to negative 12. 3 times 6 is
18.
18, so negative 3x plus 18 is equal to minus 12. Subtract 18 from both sides. Minus 12 minus 18 leaves us 12 and 18, come on. 12 and 18. 30. So minus 12 and minus 18 is minus 30. All right, now what?
Divide both sides by 30 and negative 3.
There we go. We just woke up. Divide both sides by negative 3. And x is equal to?
Positive 10.
Positive 10. So 10 and 6. And once again, you can always and forever go plug those back in and make sure it works for both equations. If it doesn't, you mess something up. So you can always make sure you for sure did these ones right. All right, 25. Solve a system of equations, same type of thing. Someone want to read these to me again?
Negative 10x
Minus 10x
minus 5y equals 0. The next equation is negative x plus 4y equals negative 17.
equals minus 17. Oops, minus 17. Okay, so this first equation, it's real easy to solve for one variable in terms of the other. So I'm going to use this equation, since it has a 0 on this side, to solve for my x or my y. Doesn't matter which one I solve for. What should we solve for? Solve for x. So I'll solve for x in terms of y. It'll be a little bit nicer if we solve for y in terms of x. So we'll do that. Move the 10 to the other side. So I get, using this equation, we get minus 5y is equal to 10x, right? Divide both sides by minus 5, and I'm left with y is equal to, if I divide that by minus 5, I'm left with y. Divide that by minus 5, I get
Negative 2.
minus 2. So y is equal to minus 2x. Okay, now I'll substitute that into our next equation. So I get negative x plus 4y is equal to minus 17. So I get negative x, 4 times negative 2 is negative 8x is equal to minus 17. Or in other words, negative 9x is equal to minus 17. Or in other words, x is equal to 17 over 9. Get rid of this, the negative cancels with the negative, making it positive. So x is equal to 17 over 9. Now we can use that to solve for y. Y is equal to negative 2 times x. What's negative 2 times 17?
34.
Negative 34 over 9. So y is equal to negative 34 over 9. Since I make some of these up, your numbers might not always come out pretty. Yeah. But you can always plug it back in. Remember, you will be allowed to use a calculator, so plugging that in should not be that hard. To check to make sure, did it work for this, did it work for this? Right? Okay. Problem 26. Oh yay, system of 3 equations. All right. Someone?
3x plus y minus z equals 11. X plus 3y equals z plus 13. X plus y minus 3z equals 11.
Okay. First thing I'm going to do on this middle equation, I want to bring the z over to the other side. So all my x, y's, and z's are on one side and my constants on another side. Just makes it so I don't make a mistake down the road. So subtract z from both sides. This would be the same thing as minus z over here equals 13. Right? Okay. So let's see. Do we see any of those that would combine together nicely to cancel out and leave us with a single variable? I don't really see it. So might be easier. Might just have to grab the bull by the horns. Pick one, solve for one of the variables, substitute into the other two, and repeat. So we need to pick one of these and solve for one of the variables. I'm just going to pick the top one and solve for z.
Yeah.
It's completely arbitrary. So I'm going to take this and solve for z. So I'm going to move z to this side and 11 to this side. So I'm going to get z is equal to 3x plus y minus 11. I moved the minus 11 over here and the positive z over there. Everyone follow the algebra there?
Yeah.
Okay, so now I'm going to substitute that z into both these equations, rewriting both these equations. So rewriting this one, I get x plus 3y minus z is equal to 13. And from this one, I get x plus y minus 3z is equal to 11. Simplify, and then I'll have two equations, two unknowns. We'll solve for one variable, plug into the other. So from here, what do we get looking at this one? So here we have x plus 3y minus 3x minus y plus 11 equals 13. How many x's do I have? I have 1 here and minus 3 there for a total of
2.
minus 2.
Minus 2.
I have 3 y's and minus y for a total of
2y.
2 y's. Subtract 11 from both sides leaves me over here just 2. So that went to that, went to that. So that was our rewriting of this equation here. Or divide both sides by 2, and we're left with, manipulating this one more time, we're left with negative x plus y equals 1. Okay. Now we need to take this equation and simplify it. Maybe I'll come do that one to the side over here. So we have x plus y minus 9x minus 3y plus 33 is equal to 11. Distributing the minus 3 to each of those. Minus 3 to that gives us our minus 9x, minus 3 to that gives us our minus 3y, minus 3 times minus 11 gives us positive 33. Okay, combined our x's and our y's. How many x's do I have total? At 1 and negative 9 leaves me negative 8. So I have negative 8 x's. How many y's do I have? I have 1 and negative 3. Leaves me negative 2. And then subtract 33 from both sides.
You get positive 22.
Negative 22.
Oh,
I have 11 and I'm taking away 33. So we're left with minus 22. Finally, divide both sides by 2, and I'm left with minus 4x minus y is equal to negative 11. Right? So we got that equation. So here's one equation, here's our other one now. Minus 4x minus y is equal to minus 11. There's our two equations. Now we have two equations, two unknowns. Pick one, solve for one of your variables, substitute into the other. So I'm going to use this, I'll solve for y, and I'll plug it into here. So from this equation, when I solve for y, I just move the x to the other side, and I get y is equal to x plus 1. Just moving the x to the other side, add x to both sides. Follow that? Now, substitute that in for y down here. So I'm left with minus 4x minus y is equal to minus 11. Distribute it out. I have minus 4x minus x minus 1 is equal to minus 11.
Hi, Eva is excused.
All right. So now, minus 4x and minus x leaves us a total of minus 5x. And then add 1 to both sides, so minus 5x is equal to minus 10. Or in other words, x is equal to 2. All right, now that I know what x is, so I have x is equal to 2. What is y equal to? Y is equal to x plus 1. So what's y? 3. So y is equal to 3. Now let's go figure out what z is. Here's probably our easiest one for figuring out z. Z is equal to 3 times x plus y minus 11. 3 times 2 is?
6.
Plus 3 is?
9.
Minus 11 is?
Negative 2.
So z is equal to negative 2. And again, always and forever, we can go take those numbers and plug them into each of those equations and it better satisfy the equation. Otherwise, we did something wrong. Next problem, problem 27. Hopefully you guys are like looking at your paper, seeing if you got the right answer, if you didn't. So far you're looking good? Hey, that's nice. All right, a collection of dimes and quarters is worth $15.25. So, our number of dimes times, we'll do 0.1, plus our number of quarters times 0.25 is equal to $15.25. So the number of dimes we have, each dime is worth 10 cents. So the number of dimes I have, plus the number of quarters I have, has a total value of this. Each dime I have is worth 10 cents. Each quarter I have is worth 25 cents. Their total value is $15.25. Okay. We have 103 coins in total. So the number of dimes I have, plus the number of quarters I have, is equal to 103. I'm trying to figure out how many are quarters and how many are dimes. This, I think, is the whole hard part of the problem. Just setting it up correctly. From here on out, we have two equations, two unknowns. Solve for one, substitute in to determine the other. Right? So I'm obviously going to take the bottom equation here to solve for one. What should I solve for? D or Q? Probably doesn't really matter that much on this. All right, we'll solve for Q. I'm going to solve for D simply because when I multiply, it's easier to multiply by that than by that. That's my only thinking ahead. So I'll solve for D. So we'll say that D is equal to 103 minus Q, right? Now, we'll take that and we'll substitute that up here. So 103 minus Q times 0.1 plus Q times 0.25 is equal to 15.25. Oh, I think you guys didn't like working with the decimals, right?
Yeah.
So I'm going to multiply both sides by 100. Just multiply both sides of the equation by 100. You with me? What I do to one side, I can do to the other. This marker's kind of dying on me. Let's try out the red. So multiplying both sides by 100, so this will be 103 minus Q. And rather than times 0.1, we're going to multiply it by 10. Because I multiplied that number by 100. And then we're going to do plus Q times 25 is equal to 1525. Doesn't change anything, just multiply both sides by 100.
Okay.
Okay, now just work it out the way you know and love. 103 times 10 is 1030, right? And then we have minus 10Q. And then we have plus 25Q is equal to 1525. Right? So I'm going to subtract this from both sides, and I'm going to combine like terms here. So let's first combine our like terms. I have negative 10 here and 25 here for a total of
15.
15. 15 quarters is equal to, now I'm going to take this and subtract away this.
495.
It's
495.
So close.
Negative 4.
No, it's not going to be negative. This minus this.
495.
405.
Oh, I thought there was one there. You kept saying it right. I messed up, not you. I don't know why I read that as 11. 495. 495 added to that gives us that. All we did is this number minus that number. Okay, now divide both sides by 15, and then just plug that into your calculator. What do you
Q
get?
equals 33.
Sorry, what?
Q equals 33.
33. Let's see. We should get 30, and then 45 is 3. 30, yep. Okay, that makes sense. So if Q is 33, and we know that our number of quarters plus our number of dimes is 103, so our number of dimes is 103 minus 33, or in other words, how many dimes do we have?
30.
Huh?
We have 73.
Just 70. Right? We're doing 103 minus 33 leaves us just 70. So 70 dimes and then 33 quarters. Okay. And again, always and forever, you can plug those in and double check that it makes sense. Next one. A tank contains 8,000 liters of a solution that is 40% acid. How much water should be added to make a solution that is 30% acid? So let's see the right way to think about this. I have 8,000 liters of something that is 40% acid. And I want it, when it's all said and done, to be a solution that is 30% acid. So I'm watering this acid down to make it 30%. What's the best way to represent this? So we're going to add water to it, but water is going to have a 0% acid solution. Let's see. Maybe if we track the portion that's not acid, I need to think to myself for a sec. 0.8 times 6 plus x times 1, and we want that to give us 8,000 plus x times 0.7. So I think that works, but that's not a very intuitive way to think about this. 8 times 6, so this would be 4,800 plus x is equal to, this would be 5,600 plus 0.7x. Let me think. Subtracting the 48 from both sides and 0.7 from both sides, over here we would get 0.3x is equal to, is that going to be 800? Am I doing that right?
Yes.
So x is equal to, let's see, what's 800 divided by 0.3?
2,666, 6 would be.
I don't like that then. I think I did something wrong. And of course I left my calculator. Let me think about this again. So we have 8,000 liters of a 40% solution. We're going to add some to it. Add water to it. So that it's a, oh, okay. Sorry, way overthought this. Did that really stupid. This is how much acid we have at the beginning. 8,000 times 0.4. This is our total acid at the beginning. We've got some solution and 40% of the solution is acid, right? If I say that I have 10 students in my class and I tell you 40% of my class passed, how many students actually passed?
10?
I have 10 students in my class. I tell you 40% passed, how many actually passed? 4. So if I have 8,000 milliliters of a solution, and only 40% of it is acid, how much acid do I actually have? And it's 40% of that, or 0.4 times that. So this is how much acid I start with, right? When it's all said and done, I added some water to it, so I have 8,000 plus however much I added, that's how much total liquid I have. And I know that when it's all said and done, it's only a 30% acid, but my total amount of acid didn't change. However much acid I had in that beaker, when I added X amount of water, my total acid's still the same. I just increased how much water there was. So our acid before and after is equal. Before, we had 8,000 liters of a 40% solution. When it's all said and done, we have some amount of a 30% solution. But our total acid is equal. The acid I had beforehand and the acid I had after is the same. If I tell you 40% of my students passed when I had 10 students, and then 10 more students joined my class that all failed, I'm now left with 20% of my students that passed the class, even though I still have a total of 4 students who passed. So I don't change how many students passed, I just change the size of my class. I introduce more failures into my class. So here, we have this much acid. We're introducing this much not acid, and when it's all said and done, this portion is going to be acid. But our total acid, when it's all said and done, is the same. Here's how much acid we have before, here's how much acid we have after, but we didn't change the total amount of acid. That's the hard part of the problem. So we're tracking acid before and after. Here's our equations. They have to be equal, because the total acid is equal. Okay, now this is easy. So 0.4 times 8 is 3,200, right? Is equal to 0.3 times 8 is 2,400, plus 0.3x. Now, this minus this leaves us with, is this still going to give me the same thing? 800 is equal to 0.3x.
Yes.
So x is equal to 800 divided by 0.3. And you're saying that's 2666?
With 0.6 repeated.
Alright, so 2667 we'll say.
Yeah.
Alright, I guess it should make sense the other way I did it. The other way I was just thinking about in terms of the water rather than the acid. But I think this is a simpler way to think about it. Okay. So there's that one. Next one, we're just simplifying an expression. I don't know if you guys could read it to me. It might be kind of hard for you to know how to read that. So we have 2x to the 7, y to the 5, all over 3x cubed y times 4x squared y cubed, right? And we just have to simplify this expression. So first thing we're going to do is multiply the terms on the bottom, then we'll cancel out top and bottom. So simplify the bottom and then cancel out. As a general rule, simplify your top, simplify your bottom, and then cancel out what you can. Our top is already as simplified as we're going to get it, so we just need to simplify the bottom. So our top is still 2x to the 7, y to the 5. Let's look at our denominator. 3 times 4 gives us 12. X cubed and x squared gives us, if you have 3 and then you multiply by 2, you're left with 5. You're saying that with a lot of confidence. X to the 5. Okay. And if I have a y here and 3 y's here, how many y's do I have?
6.
Try again. 1 and 3? Just 4. So y to the 4. Okay. Now we cancel out top and bottom. 2 cancels out with 12, leaving 6 on the bottom. x7 and x5 cancels out, leaving x2 on the top. y5 and y4 cancel out, leaving just y on the top. So it's x squared y over 6 is our answer. So simplify top, bottom, and then cancel out what you can. Let's do a second one. So for this one we have y cubed times x to the minus 3y squared all over x to the 4y squared all cubed. Now when we have this whole thing cubed, that's the same thing as listing it out 3 times. So let's simplify this. In the top, what do we have? Let's see, this term doesn't have an x. This has x to the minus 3, so when it's all said and done, we have x to the minus 3 there, right? Here we have a y cubed and a y squared for a total of y to the 5. Okay, now we have x to the 4 3 times. Remember, this is the same as listing that out 3 times. Do. So I have x to the 4, x to the 4, x to the 4. How many x's do I have? 12. It's the same thing as just doing 4 times 3. So that would be x to the 12 and y to the 6. Perfect. Okay, what do we do when our exponents are negative? Swap them to the bottom and make them positive. Or if it was negative down here, swap it to the top and make it positive. So if I take 3 x's down here, what does this x become? Huh?
If you do what?
If I bring the x to the bottom, so rather than x to the negative 3 up there, I instead have x to the 3 down here. I move it down, which makes it positive. So I have 3 and 12 gives me 15. So I have x to the 15. Y, we have 5 and 6 for a total of just y in the bottom, and then we're left with 1 up top. You never have 0 up top. We never are doing that. You still have 1, because this can be thought of as 1 times y to the 5. It doesn't change anything. So don't put 0 there, it's a 1. And that's what simplifies to. Alright? 31, scientific notation. Simplifying scientific notation. So this is 5.33 times 10 to the minus 6
Yes.
all over 9.62 times 10 to the minus 2. Okay. So first off, divide these out for me. What's 5.33 divided by 9.62?
It's one,
It's going to be 0.9.62
oh, I don't know.
9.62 divided by, or sorry, 5.33 divided by
It's
9.62.
0.55.
0.55.
40540.
Okay, 5504 gives me significant figures as we had here. We
Yeah.
got 3 there, so let's get 3 terms here. Okay, so it's giving me that times 10 to the minus 6 and 10 to the minus 2 leaves me. So we can move these ones up here if we want. So rather than having 10 to the minus 2 there, we can move them up and have 10 to the 2 there. So negative 6 and 2 leaves me with 10 to the negative 4. Right? Now we don't quite have it in scientific notation. Remember, scientific notation is number dot decimal. You always have one term that's not decimal. So I need to multiply this by 10 to shift it over 1. And if I multiply by 10 to the 1 here, I need to multiply by 10 to the minus 1 to cancel it out. So I'm going to multiply this by 10, but I'm also going to multiply it by 10 to the minus 1. That way, when it's all said and done, multiply it by 1. So the 10 into that gives me 5.54 times 10 to the minus 5. And there's our answer in scientific notation. All right. Problem 32. Simplify. This one just looks like a collect term scene. So we have 5n to the 4 plus 6n cubed, all plus 8 minus 3n cubed minus 5n to the 4. Okay, for this we're just collecting like terms. So I have 5n to the 4, and I have minus 5n to the 4. How many n's to the 4 do I have when it's all said and done? 0. They perfectly cancel out. So all my n's to the 4 cancel out. What about my n's to the 3? How many n's to the 3 do I have? 6, and minus 3 leaves me 3n cubed. And then all that's left is my 8. So all that happens is this canceled out with that, and then those two combine together to give me that. Pretty simple, just collect like terms. All right, next one has us multiplying it out. So we have 6n minus 4. And we're going to take that and multiply by 2n squared minus 2n plus 5. So I'll distribute my 6n through to each one of these, and then distribute minus 4 through to each of these, and then combine like terms. So first I'm going to distribute my 6n to each of these. So 6n to 2n squared leaves me 12n what? Cubed, because we have 1 here and 2 there. Perfect. 6n times that leaves me 6n and negative 2n is
Negative 12n.
minus 12n squared. We have 1 and 1 gives us 2. And then 6n and 5 is going to be
30n.
plus 30n. Perfect. Now distribute the negative 4 through. Negative 4 and 2n squared is
Negative 8n squared.
perfect. Next,
8n.
plus 8n. Next,
20.
minus 20, right? Okay, now just combine like terms. How many n cubes do I have?
You have
Just 12. This is my only n cubed term. So I have 12 n cubed. How many n squareds do I have? Minus 12 and minus 8 gives me,
Minus 16.
try again. Minus 12 minus 8.
Oh, it's minus 4.
What's 12 plus 8?
It's 20.
20, make it negative, minus 20. N squared. Now we have 30n and 8n gives us 38n, and then minus 20. There we go. That's 33. 34. This is one that you could use your formula for if you remember your formula. So we have 4v minus 7 times 4v plus 7. So this is of the form, we have a minus b times a plus b. You can memorize the formula, that always and forever. This gives us a squared minus b squared. Or in our case, since this is a and this is b, then this would just be equal to 16v squared minus 49. That squared minus that squared. Or you can work it out by hand and get the exact same thing. So 4v to that gives us our 16v squared. 4v to that gives us our plus, what's 4 times 7?
28.
Then negative 7 and negative 4 gives us minus 28v. And then negative 7 and positive 7 gives us minus 49. And notice the 28 and minus 28 cancel out, and you're left with that and that. So you never have to use that formula, but you have it in case you want it. All right, synthetic division. Probably some of the hardest problems for you guys. Not synthetic division, but dividing polynomials by each other. So this one we have 3n cubed
Yes,
plus 9n squared minus 64n
minus 68.
minus 68.
All over n plus 6.
N plus 6. All right. How many times does n go into 3n squared? Or sorry, how many times does n go into 3n cubed? 3n squared times, right? N times that gives us that. Okay, now we multiply by, subtract, bring down, repeat. So 3n squared times n is 3n cubed. 3n squared times 6 is 18n squared, right?
Yeah.
And now we're going to subtract this from this. Your front terms better always and forever cancel out or you did something wrong. So I'm subtracting it, so we'll make that negative, which also makes this negative. Because I'm subtracting that from that. Okay, so when we add those together, what are we left with? 0. Better be the case where we screwed up. And then 9 and negative 18 leaves me minus 9n squared. Bring down our next term, minus 64n, and repeat. How many times does n go into negative 9n squared? Negative 9n. So negative 9n times n is going to be negative 9n squared. Negative 9n times 6 is minus 54, right?
Yes.
And now we are subtracting, so flip the signs. So that becomes positive, that becomes positive. Those two better always and forever cancel out or we did something wrong. Negative 64 and positive 54 leaves me with
Negative 10.
minus 10n. Bring down to minus 68. How many times does n go into minus 10n? How many times does n go into negative 10n? Negative 10 times. So that's just minus 10. Negative 10 times that, negative 10n. Negative 10 times 6 is minus 60. We're subtracting, so that becomes positive, that becomes positive. Those cancel out. Negative 68 and positive 60 leaves us with 8. How many times does n go into 8?
Isn't that negative 8?
Oh, thank you. Negative 8. How many times does n go into negative 8?
Doesn't.
It doesn't. That's our remainder. So then this is going to be minus 8 over whatever we were dividing by. N plus 6. Good? All right, simplify. Next one, 36. We have 2 to the a to the 4. And we have that all raised to the 4. Right? Now we can think about the 2 as being 2 to the 1. When you have a term raised to an exponent, it's the same as multiplying the exponents in. Or you can literally write this out. Just write that out 4 times if you're not sure how to do this. You can easily write this thing out 4 times and see what it is. If we write out 4 times, how many 2's do we have when it's all said and done? 4 of them. So we have 2 to the 4 times, we have 4 groups of 4 A's. How many A's do we have when it's all said and done? What's that? Yeah, 4 to the 4. So it's going to be, if I have 16, yeah. We have 4 groups of 4 A's, sorry, to 16. Now finally, what is 2 to the 4? Try again. 16. So this is 16A to the 16. All right. And then another divide problem. Next divide problem, we have x cubed minus 16x squared plus 71x minus 56. And we are dividing this by x minus 8?
Yes.
Okay. How many times does x go into x cubed?
X squared.
X squared times. So x squared. So x squared times x gives us x cubed. X squared times negative 8 gives us negative 8x squared. Now we're going to subtract this, so that becomes negative, that becomes positive, add it up. Those better cancel out, we did something wrong. Negative 16 positive 8 leaves us negative 8x squared. Bring down the next term, plus 71x, and repeat. How many times does x go into negative 8x squared? Just minus 8x times, right? Multiply it out, negative 8x times x is negative 8x squared. Negative 8x times negative x is positive 64x, right? And now we're subtracting. So flip the signs. That becomes positive, that becomes negative. Those better cancel out, we did something wrong. Over here, 71 minus 64 leaves us with 71 minus 64 is 71 minus 64 is 7. What do I have to add to 64 to get to 71? If I add 6, I get to 70. Add one more. Okay. So 7x. All right. 7x, bring down to 56, so minus 56. How many times does x go into 7x? 7 times. So 7 times that gives us 7x. What's 7 times 8? 56. So it's going to be minus 56. But now we're going to switch signs, so subtract, add leaves us 0 plus 0. So it goes into it evenly. There was no remainder. Good?
Yeah.
All right, problem 38. There were 200 tickets sold for a women's basketball game. The tickets for students were 50 cents each and 75 cents for adults. Then we know the total amount of money collected. Okay, so let's see, we have students and adults. So I know the number of adult tickets sold plus the number of student tickets sold is equal to 200. That's our first equation. My second equation is the number of adult tickets sold. Each adult ticket is worth how much? 75 cents, right? So each adult ticket sold plus the value we got from each student ticket sold, each one of those is 50 cents,
Right.
was equal to 132.50. So here's our two equations. We'll multiply this one through by 100, just so that we're not dealing with decimals. So I'm going to rewrite this equation multiplying through by 100. So we get 75a plus 50s is equal to 13250, right? Okay, so we can ignore that equation now. We have two equations, two unknowns. Solve for one variable, substitute into the other. Doesn't matter which way we do it. Up here, should I solve for a or s? A. So A is equal to 200 minus s. Just subtract the s to the other side. Now we substitute that in down here, and we'll solve for s. So we have 75 A plus 50 s is equal to 13250. Okay. So 75 times 200, what does that give us? 75 times 2 is 150, then add 2 zeros. Right?
Yeah.
So 15,000 minus 75s plus 50s is equal to 13250. Subtract 15,000 from both sides and combine like terms. So negative 75 plus 50 leaves us
25.
negative 75 plus 50 leaves us
Negative 25.
minus 25. So we have negative 25s is equal to
1750.
1750. No, you did something wrong.
Isn't it
750 gets us to 14. So 1750. Did I do that right?
Yeah, 1750.
Oh. Okay. 1750. You're right. All right. Now divide both sides by negative 25. Oh, this is negative right here, right? Because we did this minus that. So we took a smaller number minus a bigger number, makes it negative. Now divide both sides by negative 25, and we get s is equal to, if we divide that by 25,
70.
what?
Negative 70.
70? 70? All right, we'll assume you're right this time. Okay, so that's the number of student tickets sold. So how many adult tickets were sold?
Subtract 75.
So 200 minus 70 gives us, oh sorry, back here. Adult tickets is equal to total minus student. 200 minus 70 is, what's 20 minus 7? 130.
Yeah.
So the adult is 130. Okay, I don't remember what we were looking for, but how many of each type? Okay, that's how many of each type. Okay, problem 39. Problem 39, we have 6 minus 3, absolute value of 1 minus 4x, and absolute value is less than minus 3. Okay, get the absolute value by itself is step 1.
So, just
So first, subtract 6 from both sides. So we get minus 3, 1 minus 4x is less than minus 9. Now divide both sides by minus 3. We get the absolute value of 1 minus 4x is less than 3. Right?
did you subtract?
Yeah, that's it.
Is it greater than?
Oh,
Is yours flipping the?
we have to flip the inequality. Because we multiply both sides by, or divide both sides by a negative number. Okay. So if the absolute value of 1 minus 4x is greater than 3, then that means whatever this number is inside of here, when we evaluate it, it has to be a number bigger than 3 or smaller than negative 3. So this breaks up into 1 minus 4x had to be bigger than 3, or 1 minus 4x had to be less than negative 3. This or this had to be the case, this or this. If 1 minus 4x is less than negative 3, if this came out to negative 4, when we took its absolute value, we get something bigger than 3. If 1 minus 4x was bigger than 3, when we take its absolute value, we get something bigger than 3. So this is true when this is the case or this is the case. So when your absolute value is greater than or equal to something, if it's greater than something, then that's going to be turned into an or. If it was like this, then that one gives us an and, or less than would give us an and. So depending on which way that inequality sign is, it tells you if it's an and or an or. So before we had an and, this time we have an or. So this is the case, or this is the case. And now, you just solve it the way you know and love. For right here, let's subtract 1 from both sides, and we get minus 4x is greater than 2, right?
Yes.
And then, from that, what do? Divide both sides by negative 4. We get x is less than minus 1/2.
Yes.
Remember, flip the inequality because we divided both sides by a negative number. If you divide both sides by a negative number, or you times both sides by a negative number, you flip the inequality. Okay, so x is less than negative 1/2. Or, let's see what this one gives us. From here, I'm going to subtract 1 from both sides. So we get negative 4x is less than negative 4. Now, divide both sides by negative 4, and we get x is greater than 1. Flip the inequality because we divided both sides by negative. So x is greater than 1 or x is less than minus 1/2. Pictorially, what does that look like? Here's 0. Here's 1. Here's minus 1. There's our 1/2 marks. So either x is less than 1/2, so starting at 1/2, not including it, going this way, or x is greater than 1, so starting at 1, going this way. In interval notation, that would be everything from negative infinity to negative 1, union together with everything from 1 to infinity. Good? Okay. Then finally, the system of 4 equations. I won't give you guys one of those on the midterm unless it's extra credit. So that's a lot of algebra to have you do when it's timed.
It's timed? How long
It's
is it?
timed
How long?
class.
Oh,
Okay, so won't worry as much about that one. Now looking at the previous ones, so we started just barely at 20. So looking at 19 and above, are there any that you want me to do? None of you ever have issues finding my YouTube page, right?
No.
So you have access to when we did the first review
Yeah.
for those types of problems. Just don't want you guys to be held up over something simple. You're good? We're all good? That's bold.
Well, I'm gonna go back.
well,
Wanting to
Anyway.
Huh?
So you're gonna forget it for next time.
Well, that's why they wanted me to record.
I know.
I know you're gonna watch this every night before you go to bed.
Could you,
I'm really good at putting you guys to sleep, right?
could you re-go over, 13?
13, sure
I
can.
know how to do it, I just.
No, that's fine. All right, so A is 34 years old and B is 14 years old. So I know A is 34 right now and B is 14. In how many years will A be twice as old as B? So this is what it is currently right now. I just want to show you how you could logic this through, and then we'll go through the math. So how much older is A than B?
Right now.
How much older is A than B?
20.
20 years older. So when is A going to be twice as old as B?
When he's 40.
When B's 40. When A's 40. When A is 40, B will be 20, and that's when A will be twice as old as B. So let's just see the logic of it. Okay. Reset, ignore that, and I'll show you the algebra for this. I know that A is equal to B's age plus 20. Secondly, I want to know when A will equal twice as much as B. So there's our two equations. And now this will tell us. We already have this solved in terms of 1, so plug into the other. So 2B is equal to B plus 20. Subtract B from both sides, we get B is equal to 20. So it's when B is 20, A is twice as old as B, so when A is 40. So there's the algebra to see it, but you could have almost just guessed by stopping and thinking about it. Like she did.
Yeah, then the question is in how many years?
Oh yeah, so in how many years will that be?
In 6 years.
So that's going to be in 6 years, because B is 14 right now. In 6 years, he'll be 20. A is 34 right now. In 6 years, he'll be 40. So thank you. Yes, the answer is 6 years. Any other ones? Hopefully, none of you guys mess up on 12, because that one keeps getting you guys over and over again. A number plus itself, plus twice itself, plus 4 times itself.
I think I got it. It's. Oh, no, this.
Okay, let's go over it. So a number
So that's
X.
X.
plus itself
X.
plus twice itself plus 4 times itself is equal to minus 112. So, added up, we have 8x is equal to minus 112. What's 112 divided by 8?
Hey, I did get it right. Haha.
There you go. Okay. I don't know, trying to guess what you guys will mess up.
I was gonna say 14, but we kind of already went over a problem like that.
For which one?
We went on problem 19, it was kind of similar.
To problem 14.
Yeah.
Yeah. Those are two automobiles driving at each other. We can do it if you want. Just say the word. Said 5?
What?
Oh. I don't know. Just heard something. Guess not. You
Yeah,
good?
Could you do 5?
I think it will be.
Can I-
On problem 3, can you do number 5?
On problem 3, can I do number 5? Sure. So, this is one that make sure you know how to simplify. There should be enough space. So, we have negative 13 minus 2 all over 2 minus negative 1 cubed plus negative 6 minus parenthesis 1 minus negative 3 and parenthesis and bracket. Like that, right? Okay, so let's simplify this. So the numerator is obviously just
Negative 15.
minus 15. Now in the denominator, let's see what we have. 2 minus negative 1 cubed. What's negative 1 times negative 1 times negative 1?
Yeah, negative 1.
Negative 1. So this is just 2 minus negative 1 plus negative 6 is the same thing as minus 6. So maybe I'll just write that as minus 6. And then we have minus. Let's simplify in the brackets. I have 1 minus negative 3. What's 1 minus negative 3?
2.
One.
Negative
No.
2.
That's not, I'm not gonna.
If subtracting a negative is the same thing as adding a positive. So 1 minus negative 3 is the same thing as 1 plus 3.
Which is going to be
4. Perfect. Okay. So let's keep going. Again, the numerator is just minus 15. In the denominator, let's see what we have. 2 minus negative 1. If we minus negative 1, that's the same thing as add 1, right? So 2 plus 1 minus 6 minus 4. Right? Okay. In the numerator, again, we still have minus 15. In the denominator, 2 plus 1 is
3.
minus 6 is
Negative 3.
minus 4 is
Negative 1.
negative 7.
What? Oh, yeah.
You can think about it as negative 10 plus 3 if you want. Negative 7. And then the negatives go out, so this is going to be 15 sevens. Good?
Yeah.
Alright. Anything else?
No. Nothing.
You're all going to ace this thing?
Hopefully.
Yeah.
No point in me even writing it up? Alright.
Wrong.
What's that?
It's just, I think that's the first answer I got, and then I checked it in my calculator, and I got a different answer. I don't know, maybe I put it in the calculator wrong.
You're saying on this one?
Yeah.
Yes. There's a real danger of you misplugging a parenthesis or doing an exponent wrong, or a lot of room for error there.
That's probably what happened.
Good chance of it. I would trust your thinking over your calculator when there's that much margin of error in entering it in. Alright, nothing else? Okay, get this up.